Good morning, all. Attendance link is posted on your class group. You can mark the attendance.
Good morning, sir.
Okay, we'll start. So in the last class, in the last class we was talking about the common mode operation. So we have already derived the maximum and minimum conditions for the common mode range. So this is the equation for the maximum voltage, and this is the equation for the minimum voltage. So these two limits we have to satisfy. So within this particular limit only we have to give the common mode input so that it will reject the signal. The differential amplifier will reject the signal. Rejection means you will not get the amplified output when you are giving the input between these two values. Now, based upon this operation of common mode of the differential amplifier, we'll be doing this problem. Okay. So please read this problem carefully. For the MOS differential pair with a common mode voltage VCM applied. So VCM is the input voltage which is applied in the common mode manner. So as shown in the figure is same as that of the derivation what we have analyzed in the previous class. Here VDD is given 1.5, VSS is also 1.5, which means that, but VSS, as you know, it is negative, so we have to consider this as negative 1.5. Even though it has been given that VSS has 1.5 volt, but in the circuit diagram it has mentioned like minus VSS. Okay, so always VSS will be negative, so we have to consider VSS as minus 1.5 volt and take VDD as 1.5 volt, and the magnitude of these two voltages are same. Then you have the transistor constant Kn dash W by L 4 milliampere per volt square. Threshold voltage is given. The total biasing current through the entire differential amplifier is 0.4 milliamps. So this 0.4 milliamps may divide among the two transistors, may be equally or it may be different. That depends upon the common mode input. If your input is within the common mode range, then you can uh, ensure that this 0.4 milliampere will divide equally among the two transistors. That is, I1 is equal to I2 is equal to 0.2 milliampere it will be. Okay, only if the input is within the common mode range. What is common mode range? That is VCM max and VCM min. Okay, you will have a maximum value for the common mode, you have a minimum value for the common mode input. So if the input will belong to this particular limit, then you can ensure that your current will divide equally among the two transistors. Otherwise it will not be the scenario. Okay, so here RD is given 2.5 kilo ohm. Neglect the channel length modulation and you need to attempt these 6 questions. So first question is you have to calculate the VOV, that is the overdrive voltage, and the gate source voltage for each transistor. You know the circuit diagram of the common mode operation. That is, here the gate and source, they are shorted together. See, the gate, they are shorted together. Similarly, the source are also shorted together. So obviously this gate source voltage is going to be equal to this gate source voltage. There is no change between those two. So that you have to find. Again, the overdrive voltage you have to find. That is, overdrive voltage is nothing but VGS minus VT. So once you can find the VOV or VGS, you can find the other parameter directly. So first question is, got the idea of the first question? That is, you have to find the VOV, that is overdrive voltage, along with the gate source voltage of each transistor. Why it is not specified VGS1 or VGS2? Because it is understood that the two gate terminals are same and the two source terminals are also shorted. So the two gate source voltages of the two transistors are going to be same. So I just mentioned VGS as such. Now coming to the second part of the question, what is second part? VCM is equal to 0. That is, you have set VCM as 0, common mode input as 0 voltage. And so we have to check whether this particular value of input voltage will come under the common mode range. We have already set a limit, VCM max and VCM min. So we have to check whether our input VCM is equal to 0 as per the question B comes under this common mode range. And based upon that, we have to find the source voltage, then the two drain currents. If it is in the common mode range, obviously the two drain currents are going to be same because the current is dividing equally among the two transistors. And then we have to find VD1 and VD2. If the two drain currents are same, means there is VD1 and VD2 is going to be same. Understood? Because VD is nothing but VDD minus IDRD. So since ID is same, obviously the drain voltages are going to be same, which means that the output V0, which is equal to VD2 minus VD1, is going to be 0. Okay, please recall that output of the differential amplifier is a double-ended output. Double-ended output means output is taking with respect to drain 2 of drain 2 with respect to drain 1. Okay, output is taking at drain 2 with respect to drain 1. So the output is nothing but the difference between the two voltages, that is VD2 minus VD1. So if your transistor or if your amplifier is working in common mode means the two signals are same as well as it lies within a particular range, then you can ensure that your current is going to be divided equally among the two transistors. As a result, the two drain voltages will be same. That you have to check from question number B. Understood? And question number C, we have to repeat the same experiment what we have done in question number B, but with a different input, that is plus 1 volt. Again, we have to check whether this particular voltage is coming under this common mode range. If it is coming under this common mode range, means then there won't be any change in current. That is, if you are trying to change the input voltage within the range itself, that is, you are not going to change this input drastically or out of this particular range. Okay, then what you will find is you will find that same current flow will takes place through two transistors. Understood? That is, there is no change in the current flow between the two transistors. It is going to be same only. So as the current is same, means there is no change in the differential output voltage, that is VD1 is equal to VD2. That is, you have to ensure with question number C, that is, you are going to change the input from 0 to plus 1 volt. Again, in question number D, you have changed the input from 0 to negative magnitude of minus 0.2 volt, and repeating the question number B, that is, you have to find all those parameters like Vs, ID1, ID2, VD1 and VD2. Then fifth question, what you're going to find is the highest value of VCM, that is the maximum value of VCM. I told you that your input should satisfy the common mode range. In that common mode range, you have set a maximum value and a minimum value. So that maximum value you have to find, provided that the two transistors will remain in saturation. And sixth question, you are going to find the minimum value allowed for Vs and hence for VCM. That is minimum value allowed for VCM. Okay, so you're going to find this minimum value. It is given that to find the minimum value, you have to consider the current source voltage like 0.4 volt. Okay, there will be always a minimum voltage across your current source. That current source voltage is given as 0.4 volt only to calculate this minimum value. While calculating all other things, you don't take this particular value. This question is applicable only to the sixth part. Be careful. Okay, that is VCS is equal to 0.4 volt. You know, don't take for all these cases, previous cases. This is applicable only for sixth cases. That is why it has been mentioned in the sixth case alone. Otherwise, it would have been mentioned in the common question. Understood? So this is nothing but the voltage across the current source, which is equal to 0.4 volt. So this particular parameter you need to take into consideration only for calculating this minimum value of VCM, not for all other cases. Okay, you have to be very careful for this. Otherwise, the entire process will be wrong if you take this 0.4 volt in all other questions. Remember that this particular parameter is given in the sixth part of the sub question, so it is only applicable to this question. So I'm going to the solution now. So in the first part, you are going to find out VOV and VGS. Already we have derived the equation for VGS in the last class, that is in the operation of common mode range. It is given by Vt plus square root of I divided by Kn dash into W by L. So all these parameters is directly given. Vt is 0.5 volt, I is given. I, what do you mean by I? I is the total bias current of the differential amplifier, that is 0.4 milliampere. That is when you add the drain currents of the two transistors, you should get 0.4. Okay, so instead of I, you can put 0.4. K n dash into W by L is given as 4 milliampere per volt square. So you can directly substitute and get the value of VGS. So once you get VGS, simply you can calculate VOV. That is, you know that overdrive voltage is nothing but the difference between the gate source voltage and threshold voltage. So VT is given. So 0.816 minus 0.5 will get you 0.316 volt, which is equal to the overdrive voltage. So any doubt in this particular portion, first part of the question, any doubt? That is, you have to study this particular formula for finding the gate source voltage of a differential amplifier working in common mode operation. Okay, once you get that particular value, you can subtract this VT value from VGS in order to get the exact value of the overdrive voltage. Any doubt in this first portion? Now, coming to the second part. In the second part, you are going to set as input as 0. Based upon that, what is this actually? This is your common mode input. Okay, why it is common mode? Because you have shorted your two input terminals. There are two gate terminals and you have shorted those two gate terminals so that your input is only 0 volt, and based upon this input you are going to find all these values. So before finding those values, what you have to find is you have to find the common mode range, and you have to check whether my input comes within this particular range, because only if it is working in common mode operation only we can say that your current is going to be divided equally among the two transistors. So to ensure that, you have to find whether your inputs is coming inside this common mode range. Common mode range means common mode range means that is between max and min values. It should come between the maximum and minimum values, so that you have to find out. So to find the range, first of all we'll be discussing, or we'll be finding the maximum value. You know the equation for maximum value. VCM max is given by VT plus VDD minus I by 2 RD. So these two equations you already got from the previous discussions. That is, yesterday's class or day before yesterday's class, we have already derived the maximum and minimum conditions of common mode range. So that equation you can directly take from the derivation and substitute all these essential parameters which was already given. So you find out that VCM max is 1.5 and VCM min is minus 0.684. See, while calculating VCM min, in that equation there is VCS. What is VCS? VCS is voltage across a current source. So please take it as 0 volt, as it is not mentioned for the first question. See, here in the first question, it is not mentioned any VCS. Even in the common question also it is not given. Only for the last question it is mentioned like 0.4 volt. So be careful that this 0.4 volt is nothing but VCS, but it is applicable only for the sixth part of the question, and it is not applicable to A to E portions. These portions it is not applicable. Fine. So while calculating the maximum and minimum value of the common mode range, we have to take VCS as 0 volt. So you got this maximum and minimum value, and now compare your input. Your input is VCM is equal to 0 volt. Obviously that comes between these two values, isn't it? 0 is much greater than minus 0.684 and much less than 1.5. So as that input comes within this particular operation, common mode range, we can ensure that your current is going to split equally. That is, ID1 is equal to ID2 is equal to I by 2. Actually, I is, what is I actually? I was 0.4. That 0.4 divided by 2 will get you 0.2 milliampere. So this much current is flowing through the two transistors, which is equal. So now you got ID1 and ID2. So next thing is you have to find VD1, VD2 as per the question. And you know the equation for VD. VD is a drain voltage. You can get the drain voltage by subtracting the drop across RD from VDD, isn't it? By subtracting the drop across RD from VDD, you will get VD1. So VD1 is VDD minus I by 2 into RD. Why I by 2? Why did you take I? Because even though the total current is I, only I by 2 is flowing through Q1 and same I by 2 is flowing through Q2. So while calculating the drain voltage, you are taking only half of the total current. So VDD minus half of the current into RD. So all these values you know, so answer is 1 volt. That 1 volt will appear at D2 also. So which means that the two output voltages are same. So the differential voltage will be 0. What is the differential voltage? It is nothing but the output at D2 with respect to D1. That is VD2 minus VD1. So that is going to be 0, or your common mode signals have been rejected by the amplifier. Fine. That is, your amplifier is not willing to amplify the input because that input comes within the common mode range. Now, along with all these parameters, you have to find Vs also, because in the question you are going to find Vs, ID1, ID2, VD1, VD2. It's already the last four parameters we have discussed. Now we'll be discussing Vs. So how to find Vs? Just go to the previous circuit diagram. What is Vs actually? Vs is the source voltage, isn't it? Vs is the source voltage. So that source voltage you can find out by subtracting this particular voltage from the input. So this is a source voltage. This node is source voltage. So that source voltage is equal to the input voltage VCM minus the gate source voltage. So these two values you already know now, isn't it? What is VCM? As far as this particular question is concerned, VCM is 0. This part, isn't it? This is 0. So 0 minus VGS already you find out, that is 0.816. So answer is negative 0.816 volt. So this much voltage appearing as source voltage. So for this part, we have found out the value of Vs, ID1, ID2, then VD1, VD2. So how did you achieve this particular conclusion that ID is going to be divided equally? By checking the range. Okay, by finding the range and checking whether my input comes between these two. Then it can conclude that your current will be splitting equally. Now coming to the third part, see, while putting a question for the question paper, it won't be all these questions will not be coming as such. Okay, maybe one or two parts will be there, but you have to study all these things. Okay, that is, if it is for 5 marks, means maybe you have to analyze the performance of this amplifier for 2 inputs. Fine. So next is we'll be applying another case, that is VCM is equal to 1 volt plus 1 volt. Okay, and we are checking whether that particular input is coming within the range. Again, VCM is equal to 1 volt. Again, that 1 volt is also coming in between these two ranges, isn't it? Because our maximum value is 1.5. So we can give any input which is less than 1.5. That is okay for us. Okay. So if you can give an input less than 1.5, means it is within the common mode range, and greater than minus 0.684. So as this plus 1 volt is greater than this minimum value and less than this maximum value, we can say that this is lying in the common mode range. Okay, so simply substitute for Vs. What is Vs? Vs is equal to VCM minus VGS. So now VCM is 1. So 1 minus 0.816 will get you 0.18 volt. So as this is in common mode range, again the two currents will be splitting equally. So ID1 is equal to ID2 is equal to 0.2 milliamps, no change. Then you can find VD1 and VD2. Again, that is going to be same. There is no change for that. Okay, because I by 2 is 0.2 only as the previous case. So what is the conclusion? That is, even though you are going to change the input from 0 volt to plus 1 volt, but still you are not going to find any change in current in the drain of the two transistors, because your input is still varying in the common mode range. Even though you have changed your input from 0 to plus 1 volt, but still that input is inside the particular range, inside the particular limit, that is common mode range, so that you can say that your current, the total current I is dividing or splitting equally among the two transistors. So as this current is splitting equally among the two transistors, the two drain voltages are going to be same. That is, they are not going to change from the previous value. It remains at this particular voltage, that is 1 volt. There is no change. So only thing is that the source voltage is getting changed. So source voltage is getting changing, but drain voltage, it keeps as such. It remains as such because there is no change in I. Okay, only if there is change in current flow through the two transistors, and only there will be variations in the output voltage. So output voltage is remaining same. Why? Because you are giving the input within that common mode range itself. It is not going out of that particular range, but you are expecting some changes in the source voltage. Why? Because that depends upon the input. So Vs is VCM minus VGS. So as VCM is keep on changing, you are going to face some changes in source voltage. Now coming to the D part, what is the D? Question number D. So in question number D also, you are going to find all these parameters, but with a different VCM. That VCM is nothing but negative 0.2 volt. So now you are going to change your input to minus 0.2 volt. Again, that comes in this particular range. See, minus 0.2 is very much less than that of the maximum value as well as greater than that of the minimum value. So what is the conclusion? Again, there is no change in current and there is no change in the output voltage. It remains at 1 volt and the current remains at half of 0.4, that is 0.2 milliampere. So still the current is dividing equally among the two transistors because it is coming under the common mode range, but you are expecting a change in the source voltage because source voltage always depends upon the input voltage, that is VCM minus VGS. So as far as this question is concerned, VCM is minus 0.2 volt, so minus 0.2 minus 0.816 is equal to minus 1.016. So by observing these three questions, that is B part, C part and D part, what you have done is you have varied your input voltage within the common mode range and you are getting same current flow which is equal to 0.2 milliampere. You are getting same output drain voltages as 1 volt. There is no change, and but you are expecting corresponding changes in the source voltage because the source voltage always depends on the common mode input. Okay, so these three parameters of the input voltage, since it lies within the common mode range, my amplified output is 0. Why amplified output is 0? Because VD1 is equal to VD2. As VD1 is equal to VD2 means the differential output is nothing but VD2 minus VD1, that is 0. Because my amplifier is double-ended, it is not single-ended. Okay, the differential amplifier is always double-ended. Double-ended means you are going to take the output at the drain 2 with respect to drain 1. So as there is no potential difference, as there is no change in the voltage, the output is 0. So irrespective of the input, but that input should within the range, then we can say that the output is 0 or the amplifier is rejecting its common mode. So that is the conclusion or the inference of B, C, D part. Now coming to the E part of the question, that is fifth sub question. What is this actually? What is the highest value of VCM? Highest value of VCM means you have to find VCM max. Already we have found out in the second part itself that you can copy this particular answer. So answer is 1.5. Is there any change? VCM max is VT plus VDD minus I by 2 RD. So there is no change. So that is nothing but your maximum value. So that particular answer you will get in the fifth portion. Then sixth portion is minimum value, isn't it? Sixth portion means you are going to what is the lowest value allowed for Vs and hence for VCM, because VCM is depending on Vs, isn't it? So you have to find the Vs value and hence for VCM. But the thing is that while calculating this, you have to take the minimum voltage of 0.4 volt to operate it properly means to operate this current source I properly. Okay, so if a current source require a minimum voltage, so this 0.4 volt is nothing but the voltage across a current source. So VCS, you no longer you can take 0 as you have done in the previous experiments. In the previous 4 analysis, you have considered all these inputs. You have checked all those inputs within the common mode range or not. So while calculating that analysis, what you have taken is you have taken 0 for VCS. Okay, but in this particular question, sixth part of this question, you are going to take VCS value as 0.4. So first of all, you will have to find out what is VCM min. Okay, VCM minimum is minus VSS plus VCS. How did you get this? Vs min. Vs is source voltage. So go back to the circuit and check whether that equation is valid or not. Vs min is, see, Vs is nothing but the voltage at the source. At the source, you are having the current source followed by a negative DC power supply. So apply KVL over this particular branch. This particular branch you can apply KVL. So here it is, the voltage across this current sources VCS, this is negative. So VCS minus VSS will get you the value of Vs. Okay. The voltage Vs is sum of the current source voltage and the negative VSS. So just add those two parameters, you will get the Vs min value. So Vs min is minus VSS plus VCS min. It is given that VCS is 0.4 minus 1.5 will minus 1.1 volt. This is a minimum value of the source voltage. Now you can find the minimum value of the common mode voltage. So this is your equation. So in that, instead of putting 0, you can put 0.4 because it is given, and all other parameters are directly given. VOV we have already find out from the first part of the question. VT is given, VSS is given. So the answer is minus 0.28 volt. So this is the common mode minimum value for 0.4 volt case. Okay, whereas in the previous question or previous part of the question, the VCM min was only minus 0.684 volt because the common current source it was 0. Current source voltage it was taken as 0, but in this question the question it was asked to find out the minimum common mode voltage for a given value of current source voltage as 0.4 volt. Understood? Instead of 0 it was given as 0.4. So that was the way of answering this particular question. This is very important. Any doubt on this question means you can ask now. Any doubts? Can I move to the next part?
Yes, sir.
Okay. So in the next part, we'll be dealing with next mode of operation, that is differential mode of operation. So far we have learned about the first mode of operation. I told you this is a differential amplifier. In this differential amplifier, you are giving two inputs. So that two inputs can be given in two ways. So one way is what we have discussed this such, that is the common mode range. Now we'll be discussing differential mode operation. Okay, so in the differential mode operation, unlike this common mode operation, we will be giving two different inputs to the two gates of the transistors or the MOSFETs. So you have two terminals, that is gate 1 and gate 2 as your input, but we are not giving same inputs to these two terminals. If you are giving VGS1, here you will be giving VGS2. Okay, where the difference between this VGS1 and VGS2 is named as VID or differential input. So what is differential input? Differential input is nothing but VGS1 minus VGS2. So if you are giving a differential input to this differential amplifier, then no longer you can say that your current is going to be split equally. Okay, because there is a difference in the input. Okay, if there is same input and if that input is coming within the common mode range, then only you can say that the current is splitting equally among the two transistors of a differential amplifier. But as far as this particular case is concerned, you are going to give a change in input voltage between the two transistors. You are providing a change in the input voltage, okay, with respect to gate of the other transistor. So if VGS1 is the input to the first transistor, VGS2 is the input to the other transistor, then obviously the difference is nothing but VID, which is given like a symbolic representation like here. Okay, so VID is nothing but VGS1 minus VGS2. So this is the actual differential input what we are giving to the amplifier. The peculiarity of this case is that you are not going to expect an equal current flow through the two transistors. So you have to specify like ID1 and ID2. Okay, so since ID1 and ID2 will be different, VD1 and VD2 obviously it is going to be different even though RD is same. Okay, because VD is VDD minus IDRD, isn't it? VD is VDD minus IDRD. If ID is different from each other, obviously these VDs are going to be different from each other. Okay, so if VD1 and VD2 are different means the output is non-zero. That is, you are getting a positive or a negative value which is nothing but not equal to 0. So if the output is not equal to 0 means now you can say that your differential amplifier is operating in differential mode of operation. It is not rejecting the signal. If it was rejecting the signal means obviously it is not working. If it is not working means it is having a common mode rejection property which we have learned in the previous operation. But this mode of operation, it is dealing with the two transistors where the currents are different. So since the currents are different means the two output terminal voltages will be different. So the differential output will be a non-zero value, which is something different from 0, having a positive value or a negative value. Normally we are taking the output at D2 with respect to D1. So if D2 voltage is greater than D1 voltage, you can say that your output is positive. If D2 voltage is less than that of D1 voltage, then you can say that your output is negative. So now, as of now, you are expecting a positive voltage or a negative voltage corresponding to your input VID. Okay, corresponding to your input VID because of the difference in current flow through the two transistors. So that we will be studying in detail for the two cases. So one is for positive case and another for negative case. So what will happen if your VID is positive? VID positive means I told you what is VID. VID is actually the difference in the input signals of VGS1 and VGS2. Okay, so VID positive means you are giving a positive signal at the gate of the transistor Q1, but you are giving a negative signal at the gate of the transistor Q2. That is VGS1 is highly positive than VGS2. Understood? I'll repeat. VID is the difference between VGS1 and VGS2. If VID is made to be positive means it is understood that the gate source of first transistor is more positive than gate source of second transistor. So under the situation, what will happen? This is which kind of transistor it is? Is it PMOS or NMOS? What about Q1? Is it PMOS or NMOS?
NMOS.
Yeah, NMOS. So being this is an NMOS transistor, it will conduct only with a positive gate voltage, isn't it? So this is a positive gate voltage is coming at this Q1, whereas a negative or lesser positive voltage is coming at the gate of Q2, which means that Q1 is conducting more because positive voltage is coming to the gate, isn't it? The Q1 is having more positive voltage when compared to Q2. So Q1 is conducting more than Q2. Okay, so for that is so most of this the I will be contributing more towards ID1 than ID2. So ID1 is greater than ID2. This I is splitting among ID1 and ID2 actually. But you can't say that now the two currents will be same. It will be different. Why? Because Q1 is conducting a little bit more than Q2. More conduction is happening through Q1. As a result, ID1 will be more than ID2. Okay. So as ID1 is getting more, what about VD1? If current is more means what about the voltage at the drain terminal? If there is a large current ID1, there will be large drop across RD because according to Ohm's law, V is proportional to I. So if ID1 is more means there is a large drop across IDRD. IDRD will be more. So VD will be VD minus IDRD, isn't it? So that IDRD, a large IDRD, when it gets subtracted from VDD, obviously this voltage is getting diminished or it is less. It is small when compared to this voltage. Because here ID2 is small. Since ID2 is small, the drop across this RD is small. So very small magnitude you are subtracting from this VDD, isn't it? For example, suppose this is 1 volt, this is 10 volt. So 10 minus 1 will become 9 volt here. But unfortunately here the drop is very large. It will be 8. So 10 minus 8 is 2 volt. So it is lesser output here. Here it is more output. Understood? I'll repeat once more. This is the switching action of the transistor, which is very much fundamental what you have studied in your electronic circuits. Okay, I'll repeat once more. Here you have given a more positive voltage at gate of Q1 and a little bit negative or less positive voltage at gate 2, which means that the Q1 being an NMOS transistor is conducting more than Q2. So ID1 will be more than ID2. So as ID1 is more, the drop across RD is more than drop across RD, this RD. Okay. So VD1 will be less because you are subtracting a large value from the fixed value. But here you are subtracting a small value from this fixed voltage. Subtracting a small value means your output will be large. But here subtracting a large value from VDD means your output will be low. So my conclusion is VD1 will be less than VD2 in this particular case. Okay. So as VD1 is less than VD2, what is your output actually? Your output is actually, I told you, it is VD2 minus VD1. It is double-ended. You are taking the output from here. The multimeter, if you are checking this output across a multimeter, the multimeter's one probe you will connect at this terminal, the other terminal will be connected over here. Rather than at ground, you will be connecting here. So you are taking the output across these two terminals, so it will be showing a positive reading, isn't it? Why it is showing a positive reading? Because VD2 is greater than VD1 as far as our discussion is concerned. So VD2 minus VD1, it becomes more positive, or your output, the differential output is positive for the case 1. Now you read this particular point. If VID is positive, VGS1 is greater than VGS2. So the Q1 will conduct more than Q2. That is ID1 will be greater than ID2. Since ID1 is greater than ID2, VD2 is greater than VD1. So VD2 minus VD1 is positive. Any doubt with this case? Is it very clear? Then I'll move to the next case. Is it clear?
Yes, sir.
Okay. Now coming to the next case, that is VID is negative. VID negative means, you know what is VID? VID is VGS1 minus VGS2. If VID is negative means obviously this is going to be less than this. So this is going to be positive. So at this gate voltage, you are going to give a more positive voltage than this particular voltage so that this VID becomes negative. So we are dealing with a negative half cycle as of now. Okay. So don't think that, see, as per the circuit diagram, you may misunderstand that you are going to connect a ground over here and you are going to connect a some other power supply, some signal, positive signal over here. Don't misunderstood. VID is nothing but a representation of a voltage, which is a difference between these two voltage. So whenever I am saying that VID is negative, understood that here it is coming negative, here it is coming positive. That's all. Okay, here you are giving more positive voltage than G1. Okay, that is gate of Q1. So whenever you apply VGS2 greater than VGS1, this transistor is conducting more. So ID2 is greater than ID1. As ID2 is greater than ID1, there is more drop across this drain resistance when compared to the drop across this one. So if you're subtracting a large value from VDD, this VD2 will be small than VD1. So VD2 is less positive or negative than VD1. Okay, VD2 is less positive means VD1 is highly positive. So your output is going to be negative because your output is nothing but VD2 minus VD1. So that will be negative when your input is negative. When VID is negative. VID negative means VGS1 will be lower than VGS2. So ID1 will be smaller than ID2 and correspondingly VD1 will be higher than VD2, which means that the differential output VD2 minus VD1 will be negative. So these are the two basic points of that is working of this differential amplifier. Now we are going to check the differential mode range, as already we have checked the common mode range in the previous case. What do you mean by common mode range actually? Common mode range was the range of input voltage which you should be given between an upper limit and a lower limit so that your amplifier is rejecting your input. That was the common mode range actually. Here also there is going to be a limit of maximum and minimum value, and care should be taken that your input should lie within these two limits so that your amplifier is now acting in a differential mode. Differential mode means the two currents will be different. It will be splitting in a different way so that VD1 will be different to VD2. If VD1 is different from VD2 means of course you are getting a positive output or a negative output which is different from zero. So we are interested to find an extreme limit of this differential input. That is how far this VID can be very maximum and how far this VID can be very less. So that we are going to find. Okay. So suppose that, so for that what you have done is you are going to give a ground voltage at the gate 2. Okay. And a very large positive voltage at gate 1. So now what is your assumption? You have given a ground voltage at gate 2 and you have given a positive voltage at gate 1, so that this current I will be almost flowing through Q1. That is, Q1 will be steering this entire current I. Okay. See, in another 1 minute this meeting will end up, but you can stay there and I'll restart the meeting. Okay, and you can join them. So don't miss this portion. 15 minutes I'll be taking the class, so don't miss this portion. So I'm telling you that you are giving a ground voltage at Q2. At the same time, you are giving a positive voltage at gate 1. Means you will be able to steer this entire current I through Q1, and at that time zero current will be flowing through ID. In the previous cases and all, ideally we have given few voltage over here and few voltage over here. Maybe one will be positive, one will be negative, or here it will be positive or here it will be negative. So like that we can split this current I. A few portion will be flowing through Q1, a few portion will be flowing through Q2. Now what I'm trying to make the entire current I flowing through Q1.